Good evening, everyone. Welcome to my class. Here I am going to discuss the topic magnetism. Here I am going to discuss few important MCQ questions, and also in description I added the theory part of magnetism and also the first part of magnetism MCQ question I discussed in the last year 2023 in the preparation of Karnataka TET. Please go through that videos also, it will be very important. Okay, theory part I explained in detail. Okay, if you are feeling, yes. Okay, Atharva, good evening. And someone in the last class, when I took the pair of linear equation, they told, ma'am, your voice is not clear, it become too low. Tell me, Atharva, now my voice is loud. Last class also I asked how is my voice, because I am taking the live, I can't listen my voice, I how it is coming in the video. Before starting the class I will check how it will come, but in the live I am not able to listen my own voice, no, how it is coming. That's why if it is too low, otherwise if it is not audible properly, please comment me, then I will check my mic. Okay. Okay, once again, good evening everyone. Let us start the class with few important MCQ question on the topic magnetism. First question, which of the following precautions are to be taken while storing a bar magnet? Which are the precautions you have to take when you are storing a bar magnet? Atharva, okay. My voice is audible clearly. Okay. First option, bar magnet should be stored in pair such that like poles are on the same side. Second option, a pair of bar magnets should be separated by a wooden piece. Third option, the end of the bar magnet should be connected by soft iron piece. Fourth option, more than one of the above. The correct answer for this question is option 2. A pair of bar magnet should be separated by a wooden piece. Why we have to separate the bar magnet with the help of a wooden piece? Wooden piece is a non-magnetic material, and also wooden is not attracted by a magnet. Then when you keep between the bar magnet wooden piece, then it will separate the magnetic field between the magnets. Then you can store, if you store that one for a long period of time, then magnetic property of that magnets, it will not at all lose. Okay. Oh yes, Yasmin, Atharva, yes, you are given the correct answer. Let us move to the next question. Which of the following materials is the most suitable for making a permanent magnet? When we are making a permanent magnet, which materials we will use? First option is, yes, nature, good evening. 1 hour before I am taking the class because I am free in this time. 9 to 10, it will become too late, no? That's why. Okay. At least before 1 hour also I am taking the class. So many are there in the live. Thank you. Okay. Which of the following material is the most suitable for making a permanent magnet? First option is steel, second option is copper, fourth option is nickel. Third option is nickel, fourth one is soft iron. Hi Ramya, good evening. Yasmin, Ramya, Atharva, yes, new teachers, they are in the live. I'm very happy those are there in the live. What is the correct answer for this question? The question, it will, which of the following material is the most suitable for making a permanent magnet? We will use steel, not soft iron. Soft iron we will use in electromagnet, not in a permanent magnet. I will explain that one in detail. Okay. Yasmin and Atharva, they are telling for soft iron we will use to make a electromagnet, not a permanent magnet. Electromagnet is nothing but, in detail I will explain. When any why we will not use soft iron for making a magnetic permanent magnet also I will explain later. Okay, when I am explaining electromagnet in detail I will explain. Then here the correct answer for this question is steel. Steel is the material is most suitable for making a permanent magnet. Let us consider a short note for a what is mean by a permanent magnet. A permanent magnet is a material that produces a persistent magnetic field without the need of an external power source. What will happen in the electromagnet? When any magnetic material, when any metal, when you pass an electric field, because of the flow of the electric field, that material it will behaves as a temporary magnet, that is electromagnet. But here we are talking about a permanent magnet. In permanent magnet, without the effect of electric field, otherwise without the pass of an electric field, permanent magnet lifelong, otherwise without the help of any external power supply, it will behaves as a magnet. Okay, these magnets are characterized by their ability to retain their magnetization independently for an extended periods once they have been magnetized. Permanent magnets, once you are convert a material into a permanent magnet, it will not lose its magnetism. Otherwise, magnetizing power it will be for a long time. But what it will happen in the case of an electromagnet, when electric flow is continuously it is flowing, then that time that electromagnet it will behaves as a magnet. When electricity is cut off, then immediately it will lose its magnetic behavior. That's why soft iron we will use in electromagnet, don't get confused. Okay, next, permanent magnets are commonly used in various applications such as electric motors, generators, magnetic sensors, speakers, magnetic levitation system. In all these are the few application of permanent magnet. Let us coming one by one. They are given in the option steel, copper, nickel, soft iron. Steel can be a permanent magnet. It need to be exposed to a strong external magnetic field. When steel is placed in a strong magnetic field, the magnetic domains within the steel align with the external magnetic field. See, steel is also a material that permanently you can create it as a magnet. Once you created steel as a permanent magnet, the when you created the steel material into a permanent magnet, then there will be a alignment of domains it will be takes place. This in detail you will study in PUC, how the alignment it will happen inside the magnetic material. If I go on explaining that only it will take more than half an hour. Okay, that's why for TET that much is not enough. When I am taking the class in HSTR, in that classes I will explain in detail how in the domain, how the alignment of magnetic lines it will takes place, everything I will explain. Steel is a material, then when you pass an external magnetic field, then you can convert steel as a permanent magnet. Then what you have to remember, after the conversion of permanent magnet, the alignment of magnetic lines it will takes place, that much you remember. Okay, that's why steel we will consider as a permanent magnet. Then copper is not used as a material for permanent magnets because it is not inherently ferromagnetic material. First of all, it is not an ferromagnetic material. Even nickel also same reason. Soft iron is not used to create permanent magnet. Soft iron exhibits ferromagnetism, meaning it can be temporarily magnetized when exposed to an external magnetic field. Don't confuse between the option steel and soft iron. Soft iron we will use to convert a to prepare a temporary magnet. Okay, this I included already, you know, temporary magnet, electromagnets, ferromagnetic, neodymium magnets. Okay, I will explain fastly. These are the important point. Those who are you are don't know properly means you at least you can recall the concept, then later it will be easy for you to answer the MCQ question. Temporary magnets acquire magnetism when they are exposed to a magnetic field but lose it when the field is removed. That one only I explained. Temporary magnets means they will behave as a magnets when they are exposed to a magnetic field. When and also they will lose their magnetic property when they are cut off of an external magnetic field. Only influence. Okay. Materials like soft iron can exhibit the temporary magnetism. Then coming to the next one, electromagnets. Electromagnets are created by wrapping a coil of wire around a ferromagnetic core, passing an electric current through the wire. Best example is solenoid. Everyone you studied in detail. Electromagnetic solenoid is an very good example of an electromagnet. What we will do in the case of a solenoid, we will take an iron nail, otherwise iron material. Then we will wrap solenoid with a copper wire. Then both the end of the copper wire we will connect a battery. What will happen when you switch on the battery? When electricity is flow inside the copper wire, then inside the copper wire you are having an iron. That iron it is start behaving as a temporary magnet, that we will consider as an electromagnet. This can be turned and on and off by controlling the flow of electricity. Electromagnets are widely used in various applications such as electric motor, relays, MRI machines. That is the uses of an electromagnets. Then coming to the next one, if you have any doubt when I am explaining, please ask me the doubt, because these are the topics definitely you have to know before answering the MCQ question. Even I included 3 link in the description. There I explained everything with the solenoid, then how the magnets they will behave, then properties of a magnet, everything in detail it is there. That's why I'm explaining fastly. If you need into detail, go through that videos. 3 videos link I given in the description. Okay, please go through that videos. Definitely it will helpful for your TET exam. Then ferromagnet materials are characterized by their strong attraction to magnetic field, the ability to retain magnetization. Common ferromagnetic materials are iron, nickel, cobalt. Even they are ferromagnetic materials, but they are we will not use this material to make a permanent magnet. Only steel we will use. Then neodymium magnet, that is not that much important. Next, let us move to the next question. The force between two magnetic poles does not depend upon. First option, pole strength. Second option, distance between the poles. Third option, shape of the magnet. Fourth one, more than one of the above. If you know the answer, please answer me. The force between the two magnetic poles does not depends upon the correct answer is shape of the magnet. Very good nature. It will not depend upon the shape of the matter. Always it will depends upon the pole strength, distance between the poles. Everything is important, not shape of the magnet. Next, very easy question. What is the direction of the magnetic field lines outside a magnet? This also very easy question. What is the direction of magnetic field lines outside a magnet? First option, east pole to west pole. Second option, west pole to east pole. Third option, north pole to south pole. Fourth one, south pole to north pole. What is the correct answer here? North pole to south pole. North pole to south pole. You can observe here, outside the magnet they are asking. Outside the magnet, always the magnetic lines they will move, they will be origin from outside the magnet. Okay, from north pole to south pole they will move like this. See the arrow mark here, from north to south they will move in this direction outside the magnet. North to south, yes Devaki, good. Yes, option 3 is the correct one. These are the important points I given. Later you can read what is it mean by a magnet, then magnetic field lines, Yes, these are the magnetic field lines. This is the very easy point. Next, magnetic materials are the materials which dash. What is mean by magnetic materials? Magnetic materials, first option, always get attracted towards a magnet. Second option, never get attracted towards a magnet. Third option, always move away from a magnet. No option is correct. Devaki is telling answer 1. No option is correct. Why no option is correct? What is mean by magnetic materials? Magnetic materials always get attracted towards a magnet, never get attracted towards a magnet, always move away from a magnet. No option is correct. Why they are given no option is correct? Magnetic material not always attracted to the magnet. Let us discuss always get attracted. Magnetic materials are the materials which dash. Okay, let us consider the theory first. Later we will conclude whether it is attracted or not attracted always. But here they are given no option is correct. Let us discuss the answer first. Magnetic materials are classified into three categories based on the behavior of materials in the magnetic field. Normally, magnetic materials we are divided into three categories. One is diamagnetic, paramagnetic, ferromagnetic materials. Diamagnetic substance, when placed in an external magnetic field, produce a produce negative magnetization. Therefore, diamagnetic substances are repelled by magnets. But here they are not asking diamagnetic materials. Here simply they are given magnetic materials. Okay, we will see. Diamagnetic materials means when these materials, when we placed an external magnetic field, they will show a negative magnetism. Means they will not get easily attracted by the magnet. Their diamagnetic materials, they will be repelled by the magnet, but they are not mentioned in the question diamagnetic substance. They are given magnetic material. Okay, but you have to remember diamagnetic substance, they will be repelled by the magnet. Next one, paramagnetic substance acquire a small net magnetic moment in the direction of the applied field. Therefore, they are slightly attracted by the magnet. Paramagnetic means they will be slightly attracted towards the magnet. Ferromagnetic materials are strongly attracted by the magnetic field. These materials retain the magnetism even when the magnetic field is removed. These ferromagnetic materials, they are very strong. They will show very strong magnetic properties. Even though when you remove an external magnetic field, they will behave as a magnet. Okay. This lagging of magnetization of a ferromagnetic substance behind the magnetic field is called hysteresis. So magnetic materials is not always attracted by a, but here if in the question they are not mentioned whether it is a diamagnetic material, para, ferromagnetic, they are not given any particular one. Here they are given a magnetic material. But if you consider this is a diamagnetic material, then no option is correct here. Even diamagnetic material, it will be repel, but here they are not given repulsion is not given. That's why here magnetic materials, it will be always attracted towards a magnet. That's why if they are mentioned exactly diamagnetic, paramagnetic, ferromagnetic, then according to the question you have to answer. But here particularly they are not given anything. Here given only the magnetic material. Then according to that one, the magnetic material always they will be attracted towards a magnet. That is correct. Let us move to the next question. The magnetic lines of force due to a bar magnet. Very important question. First option, intersect inside the body of the magnet. Second option, intersect at neutral point only. Third option, intersect only at north and south pole, cannot intersect at all. Tell me the answer. Magnetic field lines of force due to a bar magnet, whether they will intersect or not intersect. Yes, very basic. Intersect only at north south poles. Ramya is telling. Devaki, you are also telling. Yes, nature, good. The magnetic materials, they will not at all intersect at all. Where I showed, I included one diagram, no? Here, I will explain with the diagram. See here, anywhere the magnetic lines, no, they will not at all intersect. See, this is not the intersection. Here, anywhere you are seeing, no, they will not intersect. They will meet at a single point, North Pole. This is the North Pole. Here they will meet, but like intersection it will be like this. Intersection, this point, any two lines, they will cross. This one we will call it as an intersection. But here, nowhere the magnetic lines, they will never, not even a single point, they will not, and they will not get even intersect here. So many you will get confused here, North Pole, South Pole. North Pole, South Pole, here they will meet at a single point, but they will not at all, they will meet at the poles, but they will not intersect. Don't get confused. That's why I told this is the very important point. Even some you will get confused. Let us move to the next question. Which of the following statement is correct? Magnetite is a natural magnet. A freely suspended magnet always align north south direction. What is the correct answer? Magnetite is a natural magnet. A freely suspended magnet always align in north south direction. Both the statements are correct. Both 1 and 2 are correct. Yes, the magnetite is a natural magnet. Freely suspended magnet, it will align in north south direction. No, Devaki. That's why theory part you should be thorough. Don't concept wise you have to be strong. Then only you can answer MCQ question. If you don't know the theory, like magically you can't answer any MCQ question. That's why I included the theory part in the link. Two classes, theory is there, one more class is MCQ is there. Please go through the theory class. Otherwise, if you have the textbook, read, then only you can answer MCQ questions. A freely suspended magnet always align in the question is repeated north south. First option is correct. Next, a magnet is broken into two pieces. If you broke the magnet into two pieces, if these two pieces are brought close to each other, they will, what they will do? Take one magnet, then break the magnet. What will happen? Then bring two pieces are brought close to each other. They will, first option, attract each other. They will repel each other. Third one, may attract or may repel. Fourth one, neither attract nor repel. May attract or repel. See, consider here you are having a big magnet, north south pole. What will happen if you break this magnet also? The poles always, if you cut the magnet into two small pieces also, each small piece it contains two poles. Then when same poles, they will repel. When you bring two poles, opposite poles, then they will attract. Therefore, the correct answer for this question is always they will be either they will attract or repel. Understood nature? No, they will not at all only attract. See here, one magnet, big magnet, it is having north south direction. Okay, so sorry, north south pole cut into two equal. Okay, then here you are having north south. When you bring these two poles, what will happen? They will attract. Then here, this is south, this is north, then this is north south. What they will do? They will repel each other. Understood? They will repel each other. Therefore, the correct answer for this question is may attract or repel. That's why even small simple questions also we will get confused in the exam. like the way only you will lose your marks. That's why even simple topic you should be like accurate. Next question. When a magnet is sliced, transferred to the length into two equal parts, the pole strength remains dash. The length is reduced to dash. Understood? Pole strength is unchanged. The length is reduced to off. Unchanged. The length is reduced to off. Transfer. When a magnet is slide, transfers horizontal transverse like this. The transverse means like this only. This is the magnet. Transverse is like this only. Then here north south is there. When you cut like this transverse, here also north south is there. Then the magnet, okay, two equal parts, the pole strength it will be unchanged. Even if you cut the magnet into two or three slice also, the pole strength is always fixed, it will not at all change. Only the length is reduced to off equally if you cut. Okay, understood? Let us move to the next important question. Electromagnets are made up of soft iron because soft iron it will behaves as a. I'm requesting everyone after the class please make your feedback in the comment session, because so many they will see the comment, they will watch the class. In the you are giving the comment in the live classes comment no one will see. That's why I'm requesting, give me the honest feedback in the comment section how you are feeling about each class. What after the class be, give me the comment, okay, whether I have to improve, otherwise whatever the topic I am explaining, how you are feeling about my class, everything mention in the comment box. Okay, next, electromagnets are made up of soft iron because soft iron it will be behaves as low retentivity and high susceptibility. Second option, low retentivity and low susceptibility. Option 3, high retentivity and high susceptibility. Fourth option, high retentivity and low susceptibility. Let us consider what is mean by first of all retentivity and susceptibility. Without knowing these words, if we discuss the question, it will be difficult those they don't know the concept. Yes, already I explained electromagnets are materials that behaves as a magnet when a current carrying wire is wound on it. Normally, electromagnets generally lose their magnetic property once the current flow wire is stopped. Yes, this also I explained. They also acquire magnetic property quickly as soon as the current start flowing without any time lag. See, in the case of an electromagnet, when electricity is passed through a soft iron, what will happen, that soft iron it will start behaving as a magnet. Okay, once you cut off the current electricity, otherwise once you stop the current, then that soft iron is behaving as a magnet, that magnetic property it will lose. But once you connect electricity, once you allow the electricity to pass, immediately within no time lag, that soft iron it is start behaving like a magnet. Okay, that's why that is the very beautiful property of a electromagnet. Soft iron you can convert it as a electromagnet when you pass the electricity. When you cut off the electricity it will behave like a soft iron only. When again if you on the power, again immediately it will start behaving like a electromagnet. Okay, let us move to the two important points. Retentivity is the ability to retain a magnetic field after the removal of an external magnetic field. Retentivity means ability to retain a magnetic field. See, consider this electromagnet. This, when you stop an external flow, immediately it will stop its magnetic property. Retentivity means how much time after the power cutoff it will behaves as a magnet. For electromagnet, they will have low retentivity because when you cut off the power only, they will stop behaving as a magnet. It is the ability to retain a magnetic field after the removal of an external magnetic field. Therefore, electromagnets, they will have low retentivity, because within a short period of time, when you cut off the current, they will stop behaving as a magnet. Okay. Then magnetic susceptibility, it is the property of the substance which show how easily a substance can be magnetized. Magnetic susceptibility means how easily you can convert a material into a magnetic. Okay. Some materials like electromagnets, within a fraction of time, within a time lag, they will start behaving as a magnet. That therefore magnet, that one we will consider as a magnetic susceptibility. Therefore here the correct answer for this question is low retentivity, high susceptibility. Low retentivity means when you cut off the current, immediately it will stop behaving like a magnet. Then high susceptibility means when you uh, switch on the power, immediately within no time limit, immediately the soft iron, it will behaves as a magnet easily. You can otherwise high susceptibility means easily you can convert soft iron to a magnet, like that, remember. Okay. Therefore the correct answer for this question is low retentivity and high susceptibility. Recall one more time. If you are not able to understand, revise my video and listen one or two times, then you will clear all the concept. Okay. Since electromagnetic materials acquire a magnetic property quickly, they have to they have high susceptibility, means easily they will acquire the magnetic property. Therefore, high susceptibility or magnetism. Also, as soon as the okay, everything I explained, low retentivity, high susceptibility. What I explained, everything I put it in the words. Recall. It will be easy for you, because that question is very very important. That's why. Next, the magnetic field produced by a solenoid is increased by. In a solenoid, how you can increase the magnetic field? This is easy question. Easily you can answer this question. Changing the direction of current. Second option, placing soft iron core inside it. Third option, changing direction of solenoid. Fourth one, more than one of the above. What is the correct answer? Placing soft iron core inside it. In case of a solenoid, already I explained, we will use soft iron to increase the magnetic field strength. Yes, yes. What is mean by solenoid? A solenoid is a core of wire that produces a magnetic field when an electric current is passed through it. Then soft iron core is a magnetic material that can increase the strength of magnetic field produced by a solenoid. Then this, if you need full information on solenoid, please watch my theory part of the magnetic. There I explained everything. I explained how solenoid, how in the case of a solenoid, how magnetic field, how you can create. In detail it is there. Application of solenoid. These are found in the starting motors of cars, motorcycle, then secure door system. They are utilized in industrial equipment, then vehicles, agriculture vehicles. These are the few application of a solenoid. Okay. Next, how many of the following material can be attracted by a magnet? How many of the following material can be attracted by a magnet? First one is plastic, second option is carbon, third one is aluminum, fourth option is stainless steel. None of the above. Why none of the above? Let us discuss. Yes, plastic is not as a magnet. Leave. Carbon itself is not attracted by a magnet. Carbon also no. Aluminum is not attracted to a magnet. It is a non-magnetic substance. Stainless steel is generally not attracted to a magnet. However, it may contain varying amount of iron content which may attract its magnetic properties. Normally, the stainless steel we will consider as a non-magnetic material. In stainless steel also we are having so many varieties. If a particular variety of stainless steel, if it contains iron, okay, then it will behaves as it will be attracted towards the magnet. That's why none of the above. Let us move to the next question. This is Fleming left hand rule questions. The angle between the thumb and middle finger in Fleming left hand rule is, what is the angle between the middle finger and thumb in the Fleming left hand rule? First option is 90 degree, second one is 45 degree, third option is 120 degree, fourth option is 180 degree. 90 degree. Fleming left hand rule, we have to keep all the three fingers. It will be like they are, all the three should be perpendicular to each other. Perpendicular to each other means the angle between the fingers always it will be 90 degree. Let us consider in detail. Fleming left hand rule states that if we arrange thumb, forefinger, middle finger and the left hand perpendicular to each other 90 degree, okay, then the thumb point towards the direction of the force. Remember, these points are important. Based on these 3 points they may ask the question, okay. The thumb points towards the direction of force experienced by the conductor. Then forefinger point towards the direction of magnetic field. The middle finger point towards the direction of an electric field. Remember, thumb it will indicate the direction of the force. Forefinger it will indicate the direction of magnetic field. Middle finger it will indicate the direction of an electric field. Okay, more information I given that you read later. Okay, like this they will ask the question. In Fleming left hand rule, the middle finger it will represent what? First option force, second one direction of magnetic field, third option direction of current flowing through the conductor, fourth option magnetic flux. Tell me answer. Now only I explained middle finger what it will represent. 1 minute, at least few seconds I will take rest. Continuously talking, even mouth also it will start pain. Okay, option 3. What is the correct answer? Yes, the direction of the current flowing through the conductor. Good. Next, forefinger, what it will indicate? Forefinger, tell me. Yes, direction of magnetic field. Good. Next important question. Air is an example of, first option paramagnetic, second option diamagnetic, third option ferromagnetic, fourth option is anti-ferromagnetic. Tell me answer. Air is an example of an paramagnetic material because slightly in air also we are having different types of gases. Yes, the air it will behaves as a paramagnetic material. Remember. Let's let us discuss the few important differences between paramagnetic, ferromagnetic, diamagnetic materials. Paramagnetic, magnetic susceptibility is positive as well as small. Remember, these points are important. Based on these points, they will ask the question. Paramagnetic, the magnetic susceptibility, it will be positive and small. In diamagnetic, magnetic susceptibility is negative. In ferromagnetic, the magnetic susceptibility is positive and also large. Compare all the three differences. Based on these points also they may ask MCQ question. Second point, relative permeability is greater than the unity. This everything I will explain in HSTR in detail because in TET this much depth they will not ask. TET is only the entrance exam, no? Depth they will not ask, but when we are discussing, when I start the class on HSTR, then every concept in detail I will explain. Even my videos also you can observe. HSTR already I did so many classes like radioactivity. That is the heavy concept. In that case, I will everything I will explain in detail what is meant by relative permeability. Then everything in detail I will explain. But this much comparison, uh, remember and go, that much is enough. Now if I started explaining in depth, you will feel like physics it will be hectic, like concept wise it will become too much heavy. Okay, then in the case of paramagnetic, relative permeability is greater than unity, it will be greater. Next one, relative permeability is slightly less than unity, relative permeability is larger, except this point we will study later. Then paramagnetic materials, they are weakly magnetized in the direction of magnetic field, because in paramagnetic material we will magnetize that materials, it will get magnetized weakly. Okay, diamagnetic, they are weakly magnetized in the opposite direction of magnetic field. Then in ferromagnetic, they are strongly magnetized in the presence of a magnetic field. Example of paramagnetic is aluminum, sodium, oxygen, and calcium. Then diamagnetic, silicon, copper, bismuth, lead. Then ferromagnetic is iron, cobalt, nickel. Remember and go. Here oxygen we will consider as a paramagnetic material. That's why the air it will behaves as a paramagnetic. See oxygen here it is there. In the air, almost maximum percentage of oxygen it will be available. Therefore oxygen we will consider as a paramagnetic material. Remember that one. Okay. Next important question, magnetic field inside a solenoid is, here options are different. Increases from one end to another, it will be second option uniform. Option 3 varies from point to point. Option 4 none of the above. Magnetic field, they are not asking the line, they are asking the magnetic field strength inside a solenoid. Magnetic field inside a solenoid, whether it will be vary, whether it will be uniform, whether it will be increase from one point to another point. Yes, tell me. Yes, it will be uniform. Magnetic field strength inside a solenoid is always uniform. Which one is not true in the electromagnet? Not true in electromagnets. It is a temporary magnet. Option 2, its strength varies with the air gap between its poles. Option 3, polarity cannot be changed. Option 4, its strength can be changed. Which one is not true? Polarity cannot be changed. Okay, these are the few important MCQ question I discussed in the class. Okay, please tell me your feedback in the comment section. Okay, and also tomorrow I will meet with the next class, and also in the comment section tell me the topic, which topic you need next MCQ discussions, maths also, science also, which topic you are feeling difficult, you need more explanation in which topic you need, everything you mention in the comment, it will be very easy for me. And also whatever the classes I am taking, whether it is helping for you according to the syllabus or not, everything, if you give me the feedback only I will come to know whether how my classes are going on. Okay, otherwise this is live class is like in the classroom what will happen, interaction it will be there, but here continuously I am talking, I don't know whether how much percentage you are following or not. That's why feedback is very important for me. Okay, thank you everyone, thanks for listening my class. We will meet tomorrow. Okay, take care.